Hello there, it's Jay here from Jay's Vintage Junk, and I'm actually making the start of this video at the end of this video, if you know what I mean, because I've had a little faux pas with my recording. I've actually lost the first 10 minutes of my recording, which was the introduction, and all you've missed, basically, is me doing a little bit of repair work and installing the ICs there. I had to do a couple of pad repairs underneath. I thought they were actually good and I'd give them a final clean before I put the IC sockets on, and I lost connectivity on a couple of them. So I had to do some little bodge wires underneath the IC sockets and make the connections good again. That's all that you've missed. Everything else, all the other work I've done on this board so far is in the video, so don't worry about that. So let's get back to it and let's actually get on with what we're doing. Right, okay, this is our next target, which is going to need some attention. As you can see, it's very corroded. We've got a trace coming up here and we just can't get any contact around there at all, and as you can see, it's just pretty much green goo. And this is right next to where the battery actually was, so I think what we're going to have to do, we'll see if we can scrape perhaps a little bit of this green out. It does seem to break up, as you can see, like that. In fact, let's try a little squirt of some IPA. Where's the IPA? There it is. And we'll get a cotton bud in there and see if we can just oops. See if we can just clean it up a bit like this. So there's basically, I don't think there's really anything much left of that via. So we need to be able to get connectivity between that and the trace there. So I have tried touching my leads on there and I'm not getting anything through it at all. Ideally what we could do with doing is basically sucking that via out, so we've got a hole going right through, and then we can pass a wire through it and repair it, like I said before, how I did those failed pads on them IC sockets. So first off, let's try flowing a bit of fresh solder all the way over it. See, it's not even adhering to the via that. So if I pull it away, you can see there's like a tiny little bit there. There's virtually no usable copper there anymore. So we have a little scrape. You can see down there some solder right down at the bottom there. So in fact what I'll do is I'll just switch the desoldering station on, because we'll need that. And what we'll try and do, get rid of that bit of solder there. We'll try flowing a bit more solder into that hole. Which is not going in at all, that. Right, let's flick the board over. We'll just pop the board over because we want to have a look at the other side of that trace. It's going to be fun to do and keep in shot. Let's try and find out which one that is. We are looking at that one there, which is, hold on, let me see if I can get you on camera again now. Yeah. We are looking at where we've, there we go. We're looking at that horrendously corroded one, right? Is it that one there? I think it's that one there. Yeah, I think it's that one there that's all crusty and corroded. That's the one that we're looking at. And if we look at the leg coming off that, that's pretty bad as well. So we'll look at that once we've fact, let's do that with the meter now. Switch that to continuity. Now let's go in on that pad there, just make sure that's working yet. Let's come off the trace. Where's the trace? Not that one there. Oh, we have still got connectivity anyway. Let's try it a bit further back here. Yeah, that's good. So we've still got continuity through to that side of the board. Let's add a little bit of fresh solder to that point though, and we'll try and suck that out, and then we can have a look from the other side. Like I said, and I'll show you how I'm going to rectify this. So we'll put a bit of fresh solder on there. Hopefully that'll you can see that's even struggling to mix with the old solder that's on that via, and that's one of the problems. You see it's not wanting to mix very well. I might have to try a little bit of flux on that, see if that'll help. Where's my flux? There's my flux. Just clean off the end of the iron. I think we might have got a little bit more penetration then, but it's not wanting to take new solder, as you can see. We are getting a little bit there, yeah. I think we've got a bit of fresh solder in there now, so let's get the desolder pump and we'll go in. I'm probably going to block this unfortunately, but there's not a lot I can do about that. We'll go in on there and go. And there you can see we've unblocked that via. Now we'll flip over back onto the other side. Oops. And let's see if we are in the right place. Right, it should be that via there. I think that's the right one. Let's see if we can perhaps just prod through it. I think it's probably just a bit of crud still in the hole. No, there's still something there. Let's try sucking it up from this side, see if we can get all the way through there. We'll have to try and add a little bit of fresh solder first. Oh, where's my solder gone? There it is. We've got probably most of it out from the other side. Let's go back in. So we'll add some fresh solder there, see if we can get that to take. And just give it a little suck from this side as well. Don't think that solder's really taken. I'll just flip it back over onto that side and see. Ooh, let's have a look. Let me try and get you back in shot. Right, so that way, come this way. That's where we're working, yeah. Right, so let's make sure we've got these holes clear. Let's take a piece of wire. That's probably a little bit too thin, but we can try. Let's see if we can pass that wire. through the hole, and at least we know we've got the right hole. Oh no, we're not on the right hole, damn. It's where else? Get us on back where we should be. Right. That's the hole. Hang on. We'll get you out a little bit. Where are we? Where are we? Here we go. Right, now. That is the hole that we've just cleared out. That hole there is the one that we needed to clear out. I mean, it's no biggie because we'll have a bit of a clear up there anyway. But this is the one that we're actually working on. So again, we'll have to check to make sure we've got continuity between there and the via as well. Because we seem to have some crustiness around here. Let's just have a quick check with the meter. And yeah, we've got continuity, so that's good. So the damage is just on the top side, which is really good actually. That makes life a lot easier for us. So let's get that that trace there sucked out. And just add some fresh solder, because we know this is definitely blocked and very corroded on the other side. In fact, I think we're going to have to add a little bit of flux to that as well. And we'll go in and we'll try a little bit more solder. See if we can get that to adhere to the old solder that's in there, or at least a little bit mixing. It's definitely been a bit tricky, that, because of how bad the old solder is, but let's give that a suck and see what happens. So ideally we want to clear this via out. Let's see how that's done. Don't think we got it that time. Let's have a quick dig. Let's see. No, we've still got solder there, but we have brought it to the surface a little bit, so let's try flowing a little bit more fresh solder onto that. And we'll give that another go. Okay, let's give that a try again now. I think whatever's left in that hole isn't really solder anymore. Let's just spin it back over and have a look from the other side. If I hold it up, no, I still can't see through it. Right, so this is the hole that we're working on. This is the via, well, what would have been once a via. So it's all corrosion now. I think I can basically poke through it if I'm very, very careful. If I go back onto the other side, I'll get that in shot again. Where are we working? There we are, aren't we? So it's that one that we're working on. You see how it's all pushed up there where we was pushing on the other side. There we go. gone through. You see we've got a hole through there now. In fact, if I just take a piece of wire, just a single strand of wire, right, push that through the hole now. There we go. I think that's gone all the way through. Yep. I spin it over. I lost my wire. I just lost my wire. Damn it, yeah, I've just lost my wire. We'll have to do it again. We'll do it this way round. So let me get you so you can see what we're doing. There we go. So there's our, in fact, let's have a bit of a clean up before we go any further, because that's absolutely filthy on this side now. But we can see basically we've got that vire's open up again. And there was basically nothing left on this side of the vire. You know, the copper's completely gone. But we need connectivity between that trace there and the other side of the board. I'm just really hoping it doesn't also need conductivity somewhere internally to the board. Like I said, 'cause this board definitely has internal planes. Whether they're essentially not for some things, it's, you know, some could just be extra grounds. You never know what they're really being used for. There's not a great deal we can do about them if they are failed. Just have to hope that it's just this, and we can still get connectivity all the way through. Let's get a fiberglass pen, just see if we can perhaps make that a little bit better than it is. But as you can see, there's no copper there. There's no copper really left on the top of that. That's about as good as we can get it. We'll clean up again with the we'll bung the hole up with crud. The hole that we've just created that we need open to push this wire through, but let's see if we can get the wire through it. Yeah, the wire can push it out of the way. It's only bits of fiberglass. So let's push that wire through there. Once it quite a way through. In fact, there should do about. Let's flip the board back over. There's our wire. Oh, and I've pulled it out again. Damn it! In fact, let's give this opportunity to clean this side of the board as well before we actually put the wire in. That'd be the sensible thing to do, because this is looking a bit crusty as well, isn't it? So let's decrustify this. Where's my IPA? There's my IPA. See, at least we've got copper on this side, as you can see there. I scrape away, we do still have copper there to solder to. Looks unlike on the other side where it's basically all been eaten away. So we've got something there that's quite decent. Like I say, we can actually solder to that. So let's take our wire for the last time. In fact, let me break it off this piece of wire. There we go. And we're going to feed this single strand of wire down through the damaged wire. Go on, down you go. There we go. Fold that over. You can see that's there in place. We'll take some solder. Bring the end of my iron off. And we can solder that in place. And and that's not soldering very well. Did it that time. No, I think we're going to have to use a little bit of extra flux on there. Can hopefully solder it to that track there as well, but that's so this is the problem when you get this corrosion on the board. No matter you saw us clean that up, and it's still being rather awkward to solder. Anyway, let's add some fresh flux. Let's go in again and see what we can do. There we go. We'll have to just got a little bit of a peak on there, but we can just nip that down with these, like that. And then we've got to basically take off that piece of wire that we've left. Oops, that's not soldered. Look, it's come straight free. So this is the problem when you're working on really corroded boards. What we might end up having to do, if this won't take, no, that's come straight out again. What we're going to have to do is we're going to have to basically scrape away some of this trace here. We'll scrape some of this trace away and expose the copper underneath. There we go. That should be enough. That should be enough there. Right, now I should be able to tin that up, and then we should be able to solder our wire to that, pass it through the via like we did before, and then solder it on the other side. And then we might even be able to use that to help us fill the via with some extra there we go, we've got a bit of solder on there to tin it. Let's take another piece of wire. What have I done with it? There it is. We'll take another piece of wire. Just the same. We'll feed that through the pull that so it's basically over the trace, and we're going to solder that to the trace. Just get that exactly where I want it. Right, okay, there we go. I think we've got that soldered well to the trace. It's just yeah, break that excess bit of wire off. We don't need that. This steel wire can be a bit trickier than copper wire actually, but I find it better for doing these really fine trace repairs like this than enamel copper. Enamel copper's got its place when you're fixing boards, but sometimes this steel wire is just that little bit better. There we go, back in shot. Just bear with me while I get this off. If I leave it on, it's going to short on something. Come on, off you come. There we go, that's broken off. So that's through the via there. Let's spin it back over onto the other side. Right, there we go. So we've got our wire sticking out right there, you can see it. So basically it's a case of doing exactly the same on this side. So we'll scrape some of this trace away. Until we can find some copper. There's some copper. You can see there's some nice bright copper there. Right. Just clean that away with a bit of air. Okay. And we'll add a little bit of fresh flux. We'll bring that wire. This is where you snap the wire off and then you have to start all over again. Bring that wire down and nice and flat on there. Like that. And hopefully we can solder that in place nice and easy. Again, where's my solder gone? You know, you put things down on the bench and they instantly vanish. And then about a week later I find all these little used bits of solder and I have to put them in a little pot for next time. Right, okay, let's clean my iron off. Could really do with a new tip for this iron as well, it's getting a little bit tired now. And we will go in about there and we will hopefully get that to solder down. There, like that. So basically we've got it connected there and we've got it connected on the other side. Now let's again, we want to break off that excess bit of wire, and that's a good opportunity to make sure it's well soldered at the same time. Come on, where have you gone? There you are, you little bugger. Yeah, that's well soldered down, so we can snap that off. Come on, break off. There we go, that's broken off, and that's that trace reconnected to the other side. So basically I've got a few more like that to go through now. Just double check. I've checked a lot of these and they seem absolutely fine, but I'm just going to go through everything else and just double and triple check it before we get to the task of in fact I've just noticed a rather horrible via there that I'm going to investigate. So like I say, I'm just going to spend a little bit of time now just going through some other things, then we'll come right back when we start repopulating this part of the board. So back in a sec. Right, okay, we're back on this. Actually a few days have passed. The weather has been ridiculously hot here, and I don't do too well in very hot climates anymore. So I've had to give it a little bit of a rest while the weather's been ridiculous, but it's cooled down a little bit now, so I thought we'd get back on with this. And as you remember me saying, like I say, I had a little video incident and I actually missed showing putting those two sockets on down there, but you haven't really missed anything. Like I say, I'll go back through that anyway, what I did there. But basically what I did is I made sure everything was good in that section. Then I've moved on to this section here, checking all the wires, checking where there's anything damaged. I think I found one or two here that I had to do a little repair on. I had to do a repair on one of the main power rails running along there, and I actually just put a little bridge of wire just down there and soldered it between the brake. That fixed that. I've been with the tester now and tested every one of the traces and wires in this area where we've got these ICs. I can't find anything wrong there at all. So I think what I can do actually is I'm going to put two socket holders in these places here, ready for those ICs to go back on. In fact, what I might just do before I do that is, you remember me saying about just tinning up round here? Just get you zoomed down a little bit. Ooh, let's get you. That's better. You can see what I'm looking at now. It said basically around this area here where I started tinning up those traces. I think I might just have another little play around there before we actually add them sockets, because it'll be easier to do now than when obviously I've got sockets in the way. So what we will do, first what we'll do is grab the fiberglass pen, and we will go over all this and see if we can get what's left of that copper as bright and as shiny as we possibly can. There we go. Then we're going to add some decent quality flux. I really need to get some more flux. I've nearly out in this flux pen, and I much prefer this actually for doing stuff like this than the gel flux that I use otherwise. Right, let's get the soldering iron. I've got both my Antex irons on the go at the moment. One with a very microfine tip in it, which is what I was using for repairing those via tracks there, and then this one with a larger tip on it, which should be ideal for doing this. Well, sorry about that, folks. Battery failed. Nevertheless, let's carry on where we were. So we've put a little bit of liquid flux on the board there. I've got a piece of used solder braid here, and basically what we're going to do, put that on the board. When it's warmed up, just basically drag it over those damaged traces, just like that. There's a little bit there we might be able to do. There's a little bit up there we might be able to do. Like that. Oh, that does get a little bit warm. Let's have a go down here. But let's just put a little bit more flux on that. And this is just basically beefing up these slightly damaged traces. They're all making contact, but this will just protect them because they've not got any solder mask on them anymore, and it will beef them up a little bit where, like I said, they've basically worn away. Right, there we go. I think we'll get away with that. Yeah. Righty ho. Let's just run that on there like that. Just smooth it down a little bit. There we go. There we go. That looks better than it did. And then we'll. Where's my IPA gone? In fact, where's my proper? Seeing I found this in the attic, we might as well use it as proper PCB cleaner, probably from the 1990s. And we'll go in and just have a clean up. I mean, granted, it's not perfect, but it's certainly a damn sight better than all the solder mask eaten away. There we go. Let's see if I can get you zoomed in. Oops. I've got one of my soldering irons not in the correct holder there, and if I knock it, it starts melting things. Right, let's see if we can get you to focus. Come on, focus. You can focus on that, can't you? Not struggling to focus on that, but I think you can get the idea there. So that looks a lot better than some old tarnished horrible bits of copper. Right, let's see about getting some sockets on there. Let's see what we've got. think we've got something which will fit for that. That's going to work. That's going to work perfectly. Yep. No bent pins, no. This should go in because we've cleared all the holes. Damn capacitor there is just remember, this was straight on the board before, it wasn't in a socket. And that damn capacitor there's in our way. I think I'm going to have to just rock him this way a little bit. There we go, that should do it. Just to clearance that capacitor ever so slightly. Incidentally, seeing I've been away from this for a couple of days, my other capacitors have come in, so we can actually place that one that have blown its top. I've got some replacement tantalum capacitors there, 22 UF 16 volts, 10 UF at 16 volts, so I think that should do fine. That should replace that one that failed anyway. Right, so we've got that pushed down on the board like that. It's actually quite a nice tight fit in the board, so let's flip that over. And I think we can solder that in place quite easily. I will just add a little bit of fresh flux just to make life even easier. Especially because, like I said, we have had a bit of corrosion and things on the board, so it's not going to be absolutely perfect. Get my trusty old Antex iron out here. Do a few round to start off with. In fact, wear my other glasses because I can't see with these ones very well. Just swap my glasses. I should be able to see what I'm doing a little bit better. Ah, yeah, that's better. Right, there we go. That's that the IC socket soldered in. Now I won't bother cleaning it up because I know I've got to put another one in first. So let's put the other socket in first. Hopefully I've got something which is going to be suitable. I'll pick my glasses up before I lose them. There they are. Right, I don't want one of them because that's a term pin. Ah, what are them down there? I think one of these might do the job. Let's have a look. Yeah, that's gone down there. It's absolutely fine on the board there. Let's see, one of these will do. Yes, that should do absolutely perfectly once I've got it down on the board. There we go, that's gone down lovely. Right, so we can get that soldered in position now. Again, we'll flip that over. We'll use a little bit of fresh flux just along where we're soldering. Now sometimes you need to put a bit of blue tack or something to hold the IC socket in place. Fortunately with this one, because the holes are fairly tight, it's holding in there itself really nicely, so we don't have to worry too much about that. What we'll do, because it's a bigger socket than the one we've just done, again I've just melted my soldering stand, never mind. We will solder that point there, we'll solder that top point there, we'll solder that point there, we'll solder that point there. Now it's basically seated, it can't move in the board while we solder all the rest of the points, and now we can just run along. And solder. That's all good. Clean my iron up. And get a nice longer piece of solder to carry on. Now it is still red up, I know that because my glasses are slipping off the end of my nose with the sweat, so I don't know how much longer I'm going to actually be able to do this before I have to stop and then come back to it, but let's see how far we can go now. So we'll and that bit of flux really does help while you're doing this, especially like I said when the board has been corroded in the past. Though we did clean everything up quite nicely. Right there, okay, there we go. So now we can have a quick clean up around there. Again, I might as well use this PCB cleaner. We'll have a quick excuse me, just a quick scrub up round there. Get some Q-tips in. Yeah, I'm quite pleased with that. In fact, there's one, I've just spotted one pin there that didn't quite solder, so we'll just go in and we'll touch that one up. That can happen. So just go in, add some extra solder to that one. In fact, we'll add some extra solder to that one and that one. They are soldered, but you can see it's a bit of a cold joint. It will certainly benefit from perhaps just a little bit of extra solder on it. There we go, I'm happy with them now. Right, so let's have a look. What else do we really need to put on this before we can actually fire it up and see whether the board's going to do something? I'll tell you what we do really need to do is put those jumpers back there that we took off, so it can actually recognise the amount of RAM that it's got in it. So let's find some pin header we can stick on there. We should have some in here, I think. Come on, pinheader, where are you? Alright, just bear with me a second, folks. I will just find some pinheader and we'll be right back. Right, okay, I found some pinheader, so it's nothing fancy. It's not like the fancy gold plated stuff that was on here, but it'll have to do. It's what I've got, and it's better than the horrifically corroded ones that this board had on it. So we need 3 lots of 3, so that's 1, 2, 3. Okay, so let's put them in. That's 1 in there, 1 in there, and then I'll have to find some new jumpers to go on there, because again the jumpers were horrifically corroded. I won't really want to use them. We'll see if we can do this on the fly like this. We might have to well, those are holding in at the moment. Let's see what we can do. I can just solder 1 pin maybe, and then no, they've all dropped out under gravity. Never mind, let's do them one at a time. That one's still there, so we'll just hold it in place. We'll tack 1 leg. No, it's not. Hang on, let me get a bit of solder on the end of the iron. Then we'll just tack 1 leg. Okay, that's holding that in. We'll do the same with the next one. Just tack 1 leg. And put the last one back in. I'll hold it with my finger. Again, we'll tack 1 leg. There, that should hold them, and we'll have a quick inspection on the other side, make sure that they're straight. And yeah, those look reasonably straight. Happy enough with them anyway. But then what we'll do, in fact I've actually grabbed the other iron, but it shouldn't matter too much for this. And we'll solder in the opposing leg to the one we just tacked. We'll solder that in properly. I will just grab my other soldering iron because it's got a little bit more thermal mass. Well, some of those are obviously on ground pins. Then we can go back, we can re-solder that one we just tacked to start with properly. And then we'll go in and we'll solder them with, oops, got a bridge there. We'll sort that out after. Got a bridge there as well. Let's just sort them bridges out. And then I'm going to have to stop because the sweat's running down my eyes. It's too warm for me in here. Take some of the excess off with the iron, the desolder pump. And again, we'll just touch them back in. Make sure that they look something right. Damn it, there we go. There we go. There we go, happy with them now. So those are back in. So we've got our pin headers in there for our things. So basically all we've got to do now, we need to sort these chips out, because the chips are in a bit of a mess, and then the chips can go back in the board. In fact, let's do that now. Sod it, let's do that now before I wind it up for the evening. So I will put the board itself to one side. And I will grab wherever I've put them, because I'm sure I put them somewhere safe. Where did I put them that was safe? It's fatal when I put something safe because you can never find the damn thing. That's them chips there. Oh, there they are. Yeah, put them somewhere super safe and just left them on the bench, never mind. Right, put that to one side, put them to one side. We have got the two ICs that we removed from, that we removed from the board. And they can't really go back in the board in the state that they're in, so let me grab my helping hands. Let me get you zoomed out as well. Right, there we go. So, what I'm going to do is get this in. This just makes life a bit easier. I'll take the first IC and put him in there like that. And then we can get to all the pins. We'll get some flux on there. Like that. Get some solder braid, get the soldering iron, and we're just going to have a drag basically down those pins. We're just clearing all the old solder and crud and what has built up on the pins off best we can. We do want them to make a good contact with the socket that we've just added. That side doesn't look bad. This side actually looks a bit better anyway. I think this side was furthest away from the battery leakage. We'll get some fresh flux on there as well, same again. Like that. Get you zoomed in a little bit. Ooh. There we go. It's got most of the nastiness off them. I think what we will have to do is we'll have to go in with the we'll start with a little bit of IPA. We'll drop the chip down so all the pins are basically touching flat like that, so we're basically less risk of breaking them off. Give that a blast down with a bit of IPA. And get a cotton bud and we'll just see how clean we can get them. Not doing too bad, you can see the amount of crud that's just come off there. Right. It's not perfect, but not terrible. Yeah. There we go. So it's not terrible. Like that side, we'll just give that side a little bit of a going over with the old IPA and cotton bud. And we'll have a go at putting that in the board. Then we've got the keyboard controller to do as well. and we're getting close to be able to actually try this board and see whether we're going to get it to work or not. Right, there we go. It's not perfect, but it looks a lot better than it did when we started. Let's get the board back over and we can reinstate that first chip. Make sure all the pins are going to actually go in the holes. There we go. So that's back in the board. They can go back in after actually. I've still got to clean them up as well, but I'll do that off camera. In fact, the keyboard controller itself, wow. I mean, that wasn't soldered to the board, that was in a socket anyway, but that's pretty much fine. There's a little bit of corrosion, I can just spot it on that leg there. Just there. I need something I can just scrape with. Let's try that. That's it basically. Yeah, that's absolutely fine. That can go straight back on the board. So yeah, I think that's lined up. Nice tight sockets. You don't want sloppy sockets, you want nice tight sockets. So there we go. So it's starting to look a little bit more like a board. I haven't bothered putting that ISA slot back on yet. We'll do that once we actually know that the board's actually going to work. I might even bother putting the keyboard connection on at this moment. I just want to see if the board will fire up. So what I'll probably end up doing, I've got too hot now, so I'm going to have to leave it. But when I come back in, I'll I'll clean those two ICs up. If they're too bad, I'll see if I've got replacements for them. They're only 7400s, so it's not a big deal. I'll sort that out, and we'll probably have a look then at maybe first firing this board up. Oh, I'll replace that capacitor up there as well. As I said, I have got some replacements in there now. So I will say I'll come back to it when I'm getting back to that. So back in a sec. Right, okay, we are back. Actually, a few days have passed with one thing and another. As you can see, I've got the board pretty much back into a testable state now. You can see I haven't put that 8-bit part of the ISA slot back on yet because we don't need that for testing. I have put the keyboard connector back on just so, like I said, we'll get some activity when we get into the BIOS. We can actually do something with it. I haven't bothered addressing the battery yet. I don't know whether I'm going to put a CRC32 holder on there, a CR32 holder on there, and make a modification to the board, or I'm going to use that battery pin header there and use an external battery. I haven't decided how I'm going to go with that yet. But we are at the point now where we can actually at least see if we've got any life in this board. I'm happy enough to power this thing up now. I've checked for shorts along the power connector there, the AT power connector, so I've gone from ground to the 5 volts lines to the minus 12 volts lines to 12 and everything, and just made sure that we've no direct shorts on the board. I've also put that tantalum capacitor that had blown its top on the minus 12 volt rail. I've replaced that. So like I said, we're about ready to see whether this thing has got any life in it at all. So let's get that around like that. And I've got, got a power supply here. I'm going to test it. Now this isn't the power supply out of this computer, out of the case, because so far that's untested. This is one that I keep as a AT test supply. It's out of an old Oaveti that unfortunately I can't do anything with. The board's completely shot on it. But the power supply is good, and I've been through this power supply, and I know that the voltages coming out of this are absolutely bang on, or bang on's close enough. The 5 volts is bang on. The 12's a tiny little bit low, like 11.5 volts or something like that, but that's usually absolutely fine. So we will connect this up, and if you aren't aware, you haven't worked on AT boards before, the black wires on the connections always go together like that, so always remember black to black. Providing you have got the standard AT colour codes, that is, because some proprietary manufacturers, they might have used the AT connector. They might have even used the same AT pinout, but they don't always use the same AT colour codes. Right, there we go. So we've got a board plugged in. Power to there, we need some power into that. So we'll plug power into that, so our power supply is powered up. Now for initial tests, what I'm going to use is my postcard. I think it's in one of these drawers here. There it is. I'm sure if you're into this hobby, everyone that's into this hobby will probably have one of these. These used to be really expensive. I had one of these back in the 90s. Just an ISA version, like the original version of one of these. I don't actually know what happened to my original one, but I know it wasn't particularly cheap. I think this were like 12 or 13 quid or something like that, including postage, and it does PCI and ISA. But these are really useful. Not so much on like an XT, because XTs don't really give postcodes out. But even in an XT, it'll show you like your voltage lines and everything are there on the ISA bus, so it still does have a use even for that. Just realised that it goes in the board the other way, so we're not really going to be able to see it. I'll have to kind of shout out what it's doing. But what we do, we'll plug that. Let's find a nice clean. So yeah, they're all pretty clean now. We'll go in that one there. At least it'll show, because we'll see the voltage rails on the other side. At least it will show. I wonder if I can perhaps spin this round all so you can see what's going on. For some reason I thought oops, nearly knocked my vinegar off the table. Let me move that. I think I'm going to have to have a bench tidy. It's getting a little bit messy. Right. Okie dokie. Can you see it? No, you can't see that. Let me see if I can get this into a position where you lot can see it as well as me. In fact, it's better for me because I can get to the switch on the power supply better. Let me get you up like that. There we go. You can see the postcard now, can't you? You can see. Oops. You can see the LEDs there. So we've got basically minus 12 volts, plus 12 volts, plus 5 volts. The end one there is plus 3.3 volts, obviously for later boards, so that one won't illuminate. Then we've got clock ready. Can't actually read that. Frame and reset. I believe one of these, I don't know if it's, I think it's the ready, will come on and go off, or go off and, you know, come on later. I know if the board's working, it doesn't just, all the lights don't just immediately illuminate and just stay on like that. Like I said, some of them, like I think it's ready, goes off after a second when the computer's ready to boot. Right, let us see what this board is going to do. So we're all powered up. Let's see if we've got any life in the board. Right. Oh, that's not good. We're getting absolutely nothing. That's a reset, isn't it? We're getting absolutely nothing on there. Clock's illuminated. Ready's illuminated, but dimmer than the rest. The good thing is that all our voltage rails are there. We've got minus 12 volts, plus 12 volts, plus 5 volts, all showing up there. Let's try switching off and back on, just see whether that brings us up anything. So we'll turn off. We'll turn back on and watch these lights here. I think it's the reset light there that comes on initially and then goes off. So switch that back on. Yeah. So reset does light up initially and then goes off. So I think the clock and everything's running on it. but we're not getting any post errors or anything on the display there. It's just completely lined out. Now there could be a possibility that with this being a 286, and although it is quite a later 286, I think it's around about 1989 I think we figured out. So the BIOS should give postcodes. So I guess at the moment we've just not got quite got it yet. Now hang on, why is the 3.3? That's not right. For some reason we've got the 3.3 volt LED lighting and going out there. There shouldn't be any 3.3, so we've obviously got some. Let me turn the power off. We've obviously got some issue there. Yeah, because I don't think that should be illuminating at all. It should not be flashing off and on like that, because that's just a power rail. We're going to have to do a lot more work on this board. This is not going to be an easy fix a few traces, and I have had to fix quite a few traces on this board. I think there's been like at least 10 trace repairs I've had to do on this board to get it to this situation. But we're not going to have an easy time with it, I don't think. I think the next thing we're going to do is I might stick that back on. No, actually I'll probably leave it off until we can get Signs of Life on screen. I might pull a video card out and see if it's doing anything on the video, but we're going to have to get the scope out and have a probe round, see what's actually running, what's not running, and take it from there. I think I'll have to probably go over the board yet again and see if we've missed any broken traces. I mean, I've been through this board quite a lot. I've actually been working on this a fair amount of time now, and I thought I got all the damage in this area, but I'm going to have to go over it again, because we've either got a failed main IC, we've either got like bad BIOS. I mean, that's another thing we can do. We can pull them out, we can put them in the EEPROM programmer and read them out and make sure they're actually good. One nice thing is I have actually found this board online on I can't remember the name of the website, -0 something or -0 or something like that. I can't remember it off the top of my head, but there's a website online, and it's an archive of all old computer motherboards from XT up to like Pentium 2. It's all vintage stuff, and it's people basically putting board images up, documentation for the boards, like original manufacturers, whether the board's used in like more than one system and what have you. And fortunately, a lot of the times the ROM images and multiple ROM images if say there's been more revisions and what have you. So even if they are bad, which it could be, the fact that we're not getting anything on the post, there could be, you know, a bad EEPROM or something like that. They do fail. It'd be an easy matter to burn some new ones and stick them in there. But I'm going to leave it for today for the simple reason, well, for two simple reasons. I don't want this video to be too long. You know, I've tried to keep them under an hour if I possibly can. And I've got a Bose little hi-fi thing that belongs to a friend of mine that he's asked me to have a look at. So I'll clear the bench and see if I can sort that out for him, and then we'll get back to this. So yeah, I'm going to leave it there for now. It's a shame, you know, we haven't had first light, as you say, as we'd say if we're working on a vintage TV. But the board's not completely dead. You know, we're getting power rails. Nothing's gone pop or bang. We've just not quite got it there yet. So I say thanks for watching. I hope you enjoyed this update on this project. So thanks for watching and goodbye.